Okay, guys, finally, sorry for all the technical difficulties here, well beyond our control. Before I get started, full disclosure, I've been dealing with a nasty cold. If I lose my voice, I apologize in advance. That may happen. So welcome to the session on Java EE8. I'm Linda DeMichiel. I'm one of the specification leads for the Java EE8 platform. And in this talk, I'm going to be talking about the new Java EE8 release, what we accomplished, what some of the new features are. This is very much a high-level overview talk. At the end of the talk, I'll be giving you a list of pointers to sessions to where you can hear about many of the APIs from our spec leads in greater depth at this conference. So, usual safe harbor statement. I gotta confess, I'm not used to Windows anymore, so I hope I'm not going to fumble this too bad. So I'm going to start with a brief overview of some background, a little bit of the history of Java EE8, why it took so long perhaps. And then the bulk of the talk, I'm going to be talking about the JSRs and MRs, maintenance releases, that we addressed as goals in Java EE8. I'll say a few wrap-up words about our current status and our plans for the future. If you went to one of the keynotes this morning, you may have heard some things along those lines. And then finally, I'll leave you with some pointers to other presentations. So Java EE8 is the next and probably last step in the Java EE brand. In the development of the enterprise platform for us here at Oracle. So the platform has been getting bigger. Obviously, we have the web profile if you don't need the full functionality of the full platform. In this release, we followed a lot of the goals that we set for ourselves in Java EE7, namely a focus on web tier technologies, making sure we're modernized with the web tier. Continuing our trend towards ease of development, largely through leveraging the facilities offered by CDI. And then another item that we've wanted to address for a long time was modernization and simplification of the security APIs. So, quick overview of the history here. We started this work on this release when we filed JSRs back in 2014. Unfortunately, there was a period of hiatus, almost a year, as some of our spec leads got diverted to higher priority tasks internally, and it looked like we weren't making a whole lot of progress. So in 2016, when our resources again freed up, we took a step back and we looked at were we really focused appropriately, how do we get a release out with the high priority items accomplished in the time frame that we thought we were going to address, namely by 2017. So what we did was to try to focus on those items that we thought were the most important. So these were the original goals for Java EE8 in terms of the JSRs that we filed. But after we got underway, we realized that some of these were less important for new trends in the cloud and in microservices, and perhaps we should down prioritize on those. So what we did was we conducted a community survey. The goals of this were to validate whether our intuitions for how we should refocus were really appropriate. Indeed, the survey did. We thought that we should focus on web tier technologies, modernizing for the web tier, and that other areas like JMS, which was a relatively mature technology, that is less important for cloud environments. The management API that we wanted to address, again, the existing management API, well, this would have been a good modernization of it, was not heavily used, so we said, okay, maybe we don't want to prioritize there. And MVC, which was a new JSR. A lot of applications in the cloud, of course, ship headless, so MVC seemed to be less of a priority for us. What we did with the MVC JSR is we handed that off to members of the expert group, and that has been successfully completed, MVC 1.0, although it's not part of the Java EE8 platform per se. Okay, so this slide reflects the changes that we made, dropping the efforts on JMS and management, and then cutting loose on MVC. Okay, so now I want to get to the meat of this talk, which is a survey of the various JSRs. As I said before, our focus areas are going to be on web tier enhancements, ease of development through leverage of CDI, and then simplification and modernization around the area of security. So of these, most of the focus was indeed on web tier and leveraging CDI in the process, so I want to start there. Okay, JSON processing. The JSON Processing API was introduced as part of Java EE7. It was a new technology then. We wanted to continue to evolve it to keep pace with emerging standards. And there were 3 standards that were produced by IETF that we wanted to track and incorporate into the APIs for JSON processing. Namely JSON Pointer, JSON Patch, and JSON Merge Patch. We also wanted to add classes and methods to better utilize the Java SC8 Stream Operations so that you could leverage these in your quote-unquote JSON queries. Okay, so JSON Pointer, it's what its name suggests. It's just a pointer for pointing into a JSON document, for referencing a JSON value. It has a string-based syntax. And it's got methods to allow you to extract the value or to use the pointer to transform your JSON document with add, remove, and replace operations. So if we look at a simple example, we're creating a pointer. We have a document on a JSON array on our right, and it's got 2 elements, one representing Duke, the other representing Jane. They have phone numbers and so on. So we create a pointer. The pointer at this point is just a pointer. It's not yet referencing into our document. So to do that, we pass the reference to the JSON document as an argument to the getValue method of the pointer. And then we use that to extract the, we use that to extract the relevant value. So here's our document again. This time I'm going to use the replace method of JSON pointer to transform the document. And I do so in the obvious way, replacing the value of the first element of the document with a new mobile phone. JSON Patch. A patch is itself a JSON document, and it expresses a sequence of operations that you apply to a target document. And IETF defines the exact set of these operations, namely operations to add, remove, replace, to move, or to copy. So what you do is you use the JSON Patch Builder methods to create the patch, so you construct the patch, and then you apply it to the document with the apply method. The toJSON array method allows you to convert your patch. So here's another example. So we use the patch builder to construct the patch, and then let's see if I can see this without moving around so much. And then we use the replace method to we use the builder method to construct the patch. And here the patch has 2 operations: one to replace a value, and then the second to remove the second element of the array. Now, when you execute a patch, these operations are applied in sequence, so the subsequent operations of the patch can reference what was done in the previous operations of the patch, if that's what you want. So here we build the patch, and then when we apply it, the first thing that happens is the transformation of the phone, and then the second thing that happens is the removal of the second element. So merge patch is another one of these IATF standards. And the way this works is somewhat differently. You basically compare the value in the patch to the value in the original document, and then depending on how they relate, you produce your output. So if the element that the patch references is in the original document, then you transform the value that's referenced. If it's not existing in the original document, then you add it to the document. And if it's got a null value, then that says remove the element that's there in the document. And then finally, I'd like to talk about what we did with regard to support for SC8 Stream Operations. Excuse me. So here we've got what we can think of as a JSON query. We're using our contacts document again. So we're filtering here for those elements that are of female gender, and then we're extracting the names and we're collecting the results. So notice that using a built-in Java SC collector, we're extracting these as a list, but the result is a list of strings, so we're outside the JSON world. So the solution is obviously to introduce specialized JSON collectors. So this is the same query, if you will, but instead of just extracting as strings, we're now extracting in terms of a JSON array, so that you can, in general, apply subsequent operations or continue in the JSON world with your results. Okay, JSON binding. This is a new API that we added in Java EE8. What it is it's a JAXB-like API to marshal and unmarshal between Java objects and JSON documents. So it's intended as a natural follow-on to augment the capabilities of the JSON Processing API. So like other mapping APIs that we have, things JAXB or JPA, we designed this so that for convenience, one, there's a default mapping between the classes and the classes in the JSON document. And then there's a rich set of customization possibilities. So these customizations can be achieved either through annotations, which could apply to single properties or fields, or at class level for some of them. Or if you want to do something more general and even more customized than the annotations provide, there's a configuration API that you can use to execute certain transformations or customizations at runtime. The other thing I want to mention is when we started this work, there were already a number of JSON binding or JSON binding implementations out. So we wanted to be flexible and allow you to choose if you have a preferred JSON binding provider. You don't necessarily need to use the built-in one. You can choose the provider that you would like. So a couple of key APIs here. One is the JasonB Builder, which is the client's entry point into the binding API. And this gives you operations for setting the provider implementation and setting configuration properties. And it's also a factory for the JasonB class. And the JasonB is an abstraction over the operations of the framework. So this gives you your operations of from JSON and to JSON, your serialization, deserialization operations. So simple example, we have two cars. We're going to put them into a list. In Silicon Valley, maybe there are just Priuses and Teslas. I mean, they're pretty common here. And then using the JasonB APIs, we use the builder to create an instance of the JasonB class. And then with JasonB, we invoke the toJSON method to serialize these instances to a JSON document. I've cheated a little because I've done the pretty formatting. I don't know if that's a built-in customization or not, but there's certainly a formatting customization option you can use. So you can do other things. There's a default naming for property and fields. You can use annotations to change that if you like. You can use annotations to change the null behaviors, whether you want or don't want nulls to appear in your serialized JSON. And then there's a rich set of customization options. And these run from naming to ordering what sequence you want things to appear in, null handling, what you want to ignore, what you want to bring into your document or classes, formats for data numbers, encoding, and adapters. The adapter API lets you define custom mappings. So you implement two methods, adapt to JSON and adapt from JSON, and then these will get invoked for you. So here we're using JSON config. We're going to do our pretty formatting, and we're going to use a car adapter that's going to do our transformation. And then we pass this config to JasonB Builder, and it will be used when we do our serialization and deserialization. We could also specify here, again, using Builder, that we want to use a particular provider. So this is just an intermediate step in the configuration. Okay, so JAX-RS has been another really successful API for us. There were two key areas where we wanted to provide enhancements in this release. One, providing a really reactive client API, leveraging what Java SC8 added, and then support for serversent events. Serversent events were specified in the HTML5 standard. And then there's some other more minor improvements, support for JasonB entity providers to facilitate your mappings, and HTTP patch requests. So this is the way things looked in Java, in JAX-RS 2.0, stepping back a little bit in terms of client APIs. JAX-RS 2.0 introduced a client API that you could use either synchronously or asynchronously. In this case, we're using it synchronously. So you build up a request, and then you issue the request. So that's not terribly interesting, but it was a step forward. And you can specify in the client API that you want an async invoker rather than a regular invoker. And this allows you to get back your results in terms of a future. Or perhaps more flexibly, you can pass a callback to give you notification of the results of the request with a completed method here, or if the request ends in failure, then a failed method. So this gives a little bit more flexibility, and then you can check the status of this using the future. So what JAX-RS 2.1 does is it offers an improvement over the style, which gives you more flexibility, namely an RX invoker, which gives you back instead a completion stage. So in this simple example, we're passing a method to the completion stage that just basically says print it out. That's not terribly interesting, but things get more interesting when you look at the real capabilities of completion stages, namely that you can execute multiple requests, you can combine them, you can sequence them, you can choose which one you're going to go with, and then at the end of the day, we're finally going to accept and print out. So in this case, what we're doing is we're taking the two results, the completion stage results here, we're combining them, we're concatenating them, and we'll get out some kind of printout that looks like hello, bonjour at the end of the day. So serversent events is targeted allowing the client to subscribe to a sequence of event notifications from the server. The way this works is that the client establishes a connection to the server. This is an HTTP connection, but it's a long-running connection that's held until it's closed by the client, and it's reused for multiple notifications from the server. You designate this with a special media type, an event stream media type. And then an event object itself is structured. It has a payload, which corresponds to the data field, and it has other information, a name, which can be used, if you will, to identify a channel, perhaps, an ID, which you might use for some sequencing operations or keeping track of what's coming back, retry, and comment fields. So there are two sides to this API in JAX-RS 2.1. The client side uses, these are the most important interfaces at the client side, the event source, which you use to open the connection to the web target and then subscribe your consumer. It's auto-closable, but you can close it explicitly. And the inbound SSE event, which is what you're going to use to extract the notification that's been sent from the server. So on the client side, you might have something like this. We're getting back an event source, and then with this event source, we're registering the method that we want to have invoked when the event comes in. And then to kick off the flow of notifications from the server, we open the connection with the event source open method. The server side has an event sync, as you might expect. This is injected as a parameter to the resource method on the server side. The instance corresponds to a single client HTTP connection, and the server uses this to send the event to the client. SSE is, I guess you can think of it as a factory class for creating new events or creating event broadcasters and for configuring the events. So on the server, you might have a resource method that looks like this. So notice that we've designated the media type. The media type is, again, the text event stream media type is what the server-sent events maps to. And then in our subscribe method, we've injected the event sync and we've injected this SSE factory method. And then we're using the event sync to send the new event over to the client. Another big ticket item that we're addressing in the Servlet API and Servlet 4.0, because this was a fairly major undertaking, was support for the new HTTP protocol. This is another recent standard from IATF. And the goals of HTTP 2 are to overcome the limitations of the existing HTTP 1.1 protocol, namely to reduce latency, to support parallelism without requiring you to have multiple connections as a workaround to achieve parallelism, to address the head of line blocking problem, basically many performance improvements while retaining the semantics of HTTP 1.1. So this looks more or less transparent. And what makes this work, there's request-response multiplexing over a single connection with a binary framing layer. And the binary framing layer allows the frames which are sent over this connection to be identified as which streams they correspond to, so that you can demultiplex on the receiving end and extract the stream of messages that are a consistent stream of messages. It also contains a server push API. So the server can optimize by pushing data to the client in advance of the client's request for it. So then the client can cache this information. So for example, if you're sending over the data that's been requested for an HTML page, you know, or you can anticipate that maybe you want to send the CSS data early on. You want to push that out, or you want to push out other needed information before other information. There's also facilities for header compression to, again, make this protocol more efficient. So this was the big ticket item for Servlet 4.0, support for HTTP2. I believe there's a talk on Servlet 4.0 later in this conference. I'll give you the pointer. I believe the main or only user application visible feature here is the server push API, so that you can configure your pushes on from your servlet. And that looks something like this. There's a push builder API, so you can construct the push referencing what you want to push, and then headers or other information that are appropriate for the transmission of the push, and then you can push this out to the client. JSF is certainly a mature technology. This was a 2.3 release, which I think indicates that. I'm not going to say much here, except the expert group addressed an enormous number of smaller feature requests and JIRA items. When I initially prepared the slide, the spec lead told me that something like 600 some JIRA items had been resolved in this release, so it was certainly non-trivial from that point of view. But some of the things that this contains are improved integration with CDI, support for WebSocket integration, AJAX method invocation, and then leveraging Bean validation and the new date-time support. Okay, so speaking of CDI, which is a key technology for us, CDI 2.0 was a big release, but one of the main focus areas of CDI was not so much Java EE as providing support for use of CDI outside of Java EE, namely with a Bootstrap API to let you bootstrap a CDI container in SC environments. The expert group wisely split the spec into 3 parts when they were doing this. A core CDI, which is used both in EE and SC environments, and then those APIs that are specific for use in SC environments, like this bootstrapping API, and then those APIs that are used more in Java EE. Think session beans, because CDI does in fact speak of EJB session beans and how they're used in CDI. From an EE perspective, I'm going to talk here mostly about the improvements that were made in observers and events. There were a number of other features that were done, annotation literals, which are an ease of use capability, alignment with some of the new SC features, the Stream API, repeating annotations, lambdas, use of completion stage, and many enrichments to the CDI SPI. Okay, events and observers. This is what things look like in CDI 1.1 or EE, Java EE 7. You construct an event and you fire it. And when you fire it, the observers are invoked synchronously. They're invoked in the same thread as the fire method, and they're invoked in whatever order the CDI container chooses to invoke them in. In CDI 2.0, CDI made two improvements here. First of all, it gives you the ability to order synchronous events using the priority annotation. So priority is an annotation in common annotations. It didn't used to apply to parameters. We updated the common annotations with an MR so that you could do this. And now you can order your observers so that you know when an observer triggers. If you want to leverage what was done in that observer, you have this determinism. The other improvement that was made was support for asynchronous events. So when you fire an event asynchronously, you're guaranteed that there's at least one or more threads that are going to be used for the firing of the observer methods that are responding to this event. And the way you designate those observer methods is with the observes async, So as you might expect, it would be non-portable to specify priority with async observers because of the nature of being async, you're not going to be able to order them in any deterministic way. So a couple of things to note with this. One, the same type of event can be fired both synchronously or asynchronously, but the observers that are eligible for being notified of the event depend on whether they are synchronous observers, which would be notified for a synchronous event, or asynchronous observers, which would be notified for the asynchronously fired event. With an asynchronous observer, it's called in a new lifecycle context and a new transaction context, so they can't be transactional in the sense of the synchronous observers. Okay, how am I doing on time? Pretty good. Okay, bean validation. So this is another 2.0, I think for good reason. It includes many useful new features. It's modernized to leverage what Java SC8 provides. It's got support for the Java time APIs, repeatable annotations. You can apply constraints to collection elements, to optionals, and it has a host of new constraints. Some of these were already there in Hibernate Validator, and I think they had gotten a very positive reception there, so the requests were made to add these into the standard Bean validation as well. So a host of new constraints. So some of these passed. Repeating annotations. When we did all of these JSRs and the maintenance releases that I'll be talking about, we've been opportunistically introducing repeating annotations. We haven't revved specs just for the purpose of adding repeating annotations, but I think most of our JSRs have undergone enough changes that we've been leveraging repeating annotations. So that's now pretty consistent across the entire EE platform. Constraints within container elements, such as here, where you want a map of a valid customer and a valid account, or with optionals. The last example here illustrates the new annotations, the fact that your list should not be empty at the result of this, and that you want the customer emails to be non-blank strings that are configured appropriately as email addresses. Okay, the new Java EE Security API. This is something that was requested for a long time. So there are a number of key new APIs that were added here. I'm going to talk about these three. Security context, the HTTP authentication mechanism API, and identity stores. So part of the goal, or a large part of the goal, is simplification of security in Java EE, common approaches, common mechanisms, and leverage of CDI to specify, one, how these work, and two, how they're configured. So security context, this has methods for authentication. Authenticate would be used in the web tier. Get caller principal and get principals by type and is caller role. If you're familiar with the Servlet and EJB spec, you'll notice that we didn't have uniform naming across these APIs, which is generally a source of confusion and typos, I guess, when you're trying to write your applications. So these are intended to supersede the existing inconsistently used method, inconsistently named methods, which of course you can still use. So to have a common API across the different container types. The HTTP authentication mechanism is designed specifically for the web tier, for the servlet container only. It's modeled on the JASPIC server auth module SPI, but what it is it's intended to capture the, JASPIC is quite powerful, but it's very complex, and we've had a number of people concerned about the complexity, the awkwardness to use. So the goal here is to provide something that is much more user-friendly in terms of how you use it, how you define the behaviors. So the key methods of this interface are validate request, which is provided to allow the caller to authenticate. So you can extract, this is called before do filter or service method. So you can extract information from the HTTP header or the request parameter and so on. Secure response, which is invoked, as you might expect, after. And that would allow you to do things like, I guess, encrypting your response if you wanted to do something there. Clean subject lets you clean up, get rid of any caller-specific information, cookie state perhaps, or anything else that you would not want to have propagated any further. So you can package this with the application. You can package your own HTTP authentication mechanism implementation with the application, or you can use a container supplied one, and there are rules for the prioritization of these and the configuration of these. So this API, in turn, can delegate to the identity store API. Which is used to interact with the stores that have user information, both for authenticating and retrieving information like user group information. The security API spec identifies a number of types of identity stores. I believe these are extensible. So LDAP, database, there used to be embedded. I'm not sure whether that got pulled or not in the final release. You can find out more in the security talk that's later in the conference. But this is used for authentication or authorization or both. The main methods here are validate, so you can validate a credential as to whether or not that is valid and the user can proceed, or you can extract the caller groups for further authorization if, in fact, that is supported by the identity store. Identity stores can support authentication or authorization or both, and you can determine from the identity store which it supports. The HTTP authentication mechanism can leverage multiple identity stores. So it can go through several identity stores, determining whether based on a credential, the caller has the right to continue. So you can combine the results of the identity stores as they're produced. So as I mentioned, we did a number of maintenance releases as well. JPA, most of these are quite small. JPA was probably the more significant one of this list. Java Mail had a number of small improvements. Common annotations, I mentioned for priority and repeating annotations. Interceptors was just a cleanup, and WebSocket was done a while ago. We also completed a number of maintenance releases for Java SC9. And these are included in the Glassfish reference implementation. So when you use Glassfish, you'll see the results of these, but because these are SC APIs, they're not included in Java EE8 per se, which is based on Java SC8. So I promised our team I'd talk about JPA 2.2 in particular. What this adds is repeating annotation support. I think JPA was probably the poster child for annotations when it was released, so I think there are now 16 repeatable annotations in JPA. Support for date time. What we decided to do here was support mappings for those Java time types that are supported underneath by JDBC. We didn't want to get too massively creative here with a lot of customizations, but rather to build on what JDBC provided. So namely, these 5 Java time supports: local date, local date time, and offset date time. And then the ability to stream the result of a query execution. So a get result stream method added to both the query and typed query interface. And then finally, CDI injection into attribute converters. We had previously had CDI injection in entity listeners, but we had a number of requests to add this to attribute converters, so that's also there. Okay, so where are we right now? So we just released September. Yay, it's done, finally. So this chart illustrates those APIs that underwent JSR, new JSRs in Java EE8. The ones in dark blue are existing APIs that were revved. The ones in orange down below, these are new APIs that were added to the platform in Java EE8. If we look at the web profile, which is a subset, notice the addition of both JasonB and security. Comment about security here. The security API leverages the JASPIC servlet profile. So we needed to add JASPIC also to the web profile, but only the servlet profile support is required. Okay, so where are we going? Well, where we are going is to Eclipse. So we're moving, as you may well have heard, we're moving Java EE to the Eclipse Foundation. I believe that the name of this is EE4J, at least that was the latest that I heard. And we have the great support of IBM and Red Hat in this move. We approached them first to make sure that, just to validate that this was the right direction, and we got very strong agreement here. We think that this will lead to a more agile and flexible development process, more open. It will allow things to move more quickly, perhaps. The details are still being worked out. We expect this process to go fairly quickly. We're being quite aggressive in trying to get this worked out. So this is the future. We think it will be more open going forward. We've gotten a lot of positive feedback on this move, so there's a lot of excitement, and I think we're off to a good start. Couple of the details here, we're transitioning Glassfish, the RIs, the TCKs, the product docs, the mailing lists, I think. And Oracle will continue to be providing support through Java EE8 to our customers and to the community, and then we're off and running under Eclipse. So I'm just going to leave you with a couple of pointers here where you can learn more. If you want to stay in this room, I noticed that Ed Burns, who is one of our spec leads for the Servlet API, and Xinhui Chen have just come in. So they're going to be talking here about Servlet 4.0, if that's what interests you. And then later today, there's a panel discussion on the move of Java EE to the Eclipse Foundation. So participants from Oracle, IBM, Red Hat, and the Eclipse Foundation will be present there. And then as the week goes on, we'll have other spec leads describe some of the new features of many of the other APIs in this platform. I'll put in a plug for the JCP BOF tomorrow night. That's going to include a number of the spec leads. I hope to be there as well, where you can ask questions and interact more informally with members of the community. So with that, I don't know if I have time for any questions. I think I need to leave to get these guys set up. But I'll be in the Hacker Garden this afternoon, so if anybody wants to corral me there, I'd be more than happy to meet with you and answer any questions. So thank you.